Okay, so I'm looking at the CGP book, 11 plus maths for the CEM test, the practice book, 9 to 10. I'm on units and measurements, which is section 6, page 39. Choose the most likely unit from the option to replace the question mark in these sentences. Circle the correct answer. So we have question 1. A human weighs 60. So I'm thinking about humans. I'm thinking about myself. You need to think about yourself. You need to, and the people need to think about themselves. So if you're weighing them, are you going to weigh in grams? What would you weigh in grams? Give me a few examples. What about in meters? Do you weigh meters? What do you weigh? What do you measure in meters? Is it length? Is it mass? Or is it capacity? So you've got to eliminate 2, and we know that meters is to do with length. So if you've got, think about your room and think about what's around you in terms of the length of that room. So it might be 3 meters, 4 meters by 2 meters, or 3 meters. So that's for length. It's not to do with the weight. Kilograms. So which category of measurements does kilograms fall into? Kilograms falls into, does it fall into length? Does it fall into capacity? Does it fall into length, capacity, or does it fall into mass? So it falls into mass, does kilograms. And what about kilometers? Well, kilometers is to do with length. So there's 2 measurements there in A, B, C, D, which are to do with mass. One of them is grams and another one is kilograms, because we know that meters and kilometers is not to do with weight. So we eliminate grams because small things are measured in grams. Okay, so now let's think about a giraffe. A giraffe is about 4.95 something tall. So question 2. So you have centimeters. Centimeters to do with length. You have meters. Meters, length. You think about your room, the length of your room, or the length of your garden. What about kilograms? Kilograms is to do with mass. So far we had centimeters and meters, and then we had kilograms. So centimeters and meters is to do with length, whilst kilograms is to do with mass. What about kilometers? The word kilometers, meters is to do with length. Kilo meaning 1,000, 1,000 meters. So there's 3 things. There's A, B, C, and D. A, B, and D are all to do with length. A, B, and D are to do with length. What about C? C is to do with mass. So we can deliberately and directly eliminate C. But centimeters, well, we might measure a table in centimeters, small things. Is a giraffe small? No. What about meters? What about kilometers? So meters, let's think about meters. Now, if you think about meters, then your room again is in meters. The height of this building, well, like this, how many meters is this? 1 meter, 2 meters, 3 meters, 3.5 meters, perhaps. What about a giraffe? Can put a giraffe behind me. Can you imagine a giraffe behind me? Its head, where will it be? Up there? So we've got or even probably higher. But what about kilometers? When would you measure kilometers? From here, from Batley to London, would be measured in kilometers because it's sensible. It's a sensible measure. So it might, here to London might be, say, for example, if it's 200 miles, 210 miles, then it's going to be, say, 7.21, say 350 kilometers. So, again, what are we doing? We look at each unit, we say, okay, where is it used? Centimeters in small things, meters in things like rooms or heights of rooms, kilometers for long distances. From here to Pakistan might be for 4,000 miles, or from here to India would be 5,000 miles, or also not miles, sorry, kilometers. So this is what you've got to, this is how you eliminate, this is how your thought processes should be. Your thought processes should be so that when you're thinking about a giraffe, you think, you put a giraffe next to a room, okay, the height of a room. And when you say, okay, what's the height of a giraffe? Well, it's going to be definitely taller than this room is the giraffe. But it's going to be meters, but definitely not in kilometers, because kilometers are for longer distances from Batley to Hemingway, Batley to Dewsbury, and a giraffe isn't going to be that long. It's tall, its height is tall, definitely it is tall, but it's definitely not going to be the height of here to Dewsbury. Right, so you have a bucket. Can you imagine a bucket? What am I doing? I'm imagining. You might think of the word bucket because you might prefer to think about the word. I like to imagine, so I use imagination, but most people, there will be a crossover. They all work together. So it can hold about 18 something of water. Okay, so what's the definition of mass? Weight. In the earlier question, we measured the weight. What's the definition of length or distance? That's to do with measuring the length of a book, or the length of this pin in millimeters, or this point, should I say? Or and what about, so what is a bucket going to measure? So a bucket is to do, what goes into a bucket? Water goes into a bucket. So it's a liquid, isn't it? So what do we measure liquids in? Yeah, we measure liquids in capacity. That's right. Okay, so can you see the differences? Length, weight, measure me, or you think of a bucket, and you have water inside it, and you place some water, it's liquid, and therefore it's capacity. Okay, so question 4. A cake contains 125 something of sugar. Sugar contains what length of sugar? Capacity is sugar liquid? Yeah, sugar is mass. So when you're weighing me or you or your dad or whoever, then you're thinking about mass. And mass is to do with small things are to do with grams, larger things are to do with kilograms. And so a cake contains 125 something of sugar. 125 something of sugar. Let's look at what choices. A is G, grams. Sugar, grams. Sugar's not that big. So some perhaps centimeters. It's not length, so definitely not B. Kilograms. You might get a pack of sugar, but will the pack of sugar go into a cake? So if it's 125 grams, how heavy is that? Or what would 125 kilograms be? Would 125 kilograms go into a cake? 1 kilogram being heavy, 125 would be very heavy. So think about it. Think about it. You see how I make the comparisons? I'm making comparisons. So I know what 1 kilogram looks like in weight. But I'm multiplying it by 125 because it says 125. So would that work? It definitely wouldn't work, would it? It definitely wouldn't work. So what do you do instead? I'll tell you what you do. Let's go on to kilograms. So kilograms isn't going to work. It's 125 kilograms. It's just far out. Meters for D, that definitely is the wrong type of measurement. It's the measured in length, and we're here trying to measure here the mass. So there's three things: mass, length or distance, and capacity. And this is not to do with liquids. This is not to do with length. This is to do with weight. There's two choices. There's grams and kilograms, and the most sensible one is grams. Why? Can you see how I was drawing comparisons? Okay, so Mount Everest is about 8.8 something high, 8.8 centimeters. Mount Everest, the largest mountain in the world, very much doubt it. What about Mount Everest is about 8.8 something meters. Meters? 8.8 meters, 8.8 meters. So this must be 3.5 meters, maybe. 1, 2, 3, 3.5 meters. The largest mountain in the world, is it going to be 8.8 meters? Well, if this is 3.5 times it by 2 is 7 meters. So you're saying the mountain is going to be 7 meters or nearly as big as this 2 floors of this? I very much doubt it. Liters. Height. We use liters for length? No. Mass? No. Capacity? Yeah, because it's liquid. So, but we're not measuring a liquid, we're measuring the height of something, the length of something, the distance of something. So kilometers sounds about right. So kilometers is like a fair distance. So it's not liters, it's not meters, it's not centimeters. Centimeters too small, meters still too small. Liters, different metric completely, doesn't apply here. And kilometers, well, kilometers is definitely kilometers because it's the appropriate distance. So say, for example, if you're measuring from here to Dewsbury or here to Morley or here to Leeds or here to Leicester or here to London or here to Pakistan or here to India or here to Sudan or wherever it is, it's gonna be in kilometers. Definitely not in millimeters. Would be too big a number. Too many digits, 000 something. So it wouldn't work. So it's kilometers. Now a mug. I now built a pattern that humans are weight, giraffes are height or length or distance or height. Bucket is to do with capacity. Sugar in a cake is to do with mass. Mount Everest is to do with height. And a mug, what's a mug to do with? So a mug. Okay, imagine a mug. What goes into it? Milk, tea, water. Okay, so how much does it hold of coffee? How much does it hold? 250? 250 what? It's not going to be kilometers. That's silly, because that's length. What about milliliters? Milliliters? Mum's medicine, like she gives you, Calpol, little spoon, 5 millimeters, 10 millimeters, something like that, 10 millimeters. So that's too small a unit. Milliliters, millimeters, they're all very small. The sound of it, millimeters. Millimeters obviously for length, milliliters for capacity. Kilograms, we're not measuring the weight, we're measuring what? We're measuring liters, we're measuring capacity, so it's going to be in liters. So sorry, I'm going to go back to that one. Liters is definitely not it, because when we're thinking about milk, that's going to be 2 point something liters or 4 point something liters. So it's going to be milliliters. So because this is only 200, this is 250, because if you make sense out of this, if milk is 2 liters or 4 liters in a drum or 2.2 something liters, then how can coffee be 250 liters? 250 liters. In 1 liter, there's 1,000 milliliters. 1 liter, there's 1,000 milliliters. A quarter of 1,000 is 250. A quarter of 1,000 is 250. So if a quarter of 1,000 is 250, then it's going to be 250 milliliters. A quarter of a liter. So it's not going to be 250 liters. Look, study them numbers. 250 liters. Milk, 2 liters, 250 liters. That's a tank. That's huge. That isn't going to work. But milliliters will, because it's just a quarter of a liter. Because when you have your milk, a quarter mug is about that big. Yeah. So it's going to work, isn't it? Now, question 7. Eve runs a race that is 5 kilometers long. 5 kilometers long. Kilometers is length. Kilometers is to do with distance. I know that 1 kilometer is 1,000 meters. Kilo meaning 1,000. So how far did she run in meters? Always start with a conversion. Always start with a conversion. 1 meter, 1 kilometers equals 1,000 meters. 1 kilometer equals 1,000 meters. Second line or third line, right? 5 kilometers. How do you go from 1 kilometer to 5 kilometers? How do you go from 1 kilometer to 5 kilometers? So you got 1 meter equals 1,000 meters. 1 kilometer equals 1,000 meters. How do you go to 5 kilometers? Where did I get the 5 kilometers from? From the question. Where did I get the conversion from 1 kilometer equals 1,000? I got it from where? Where did I get it from? So think about it. So I got it from my mind. I need to remember that. I times it by 5. 1 kilometers times 5 is 5. Whatever I do on the left, I need to do on the right. And you need to remember this. You need to do the same on the right hand side to keep it equal. Because 1 kilometer equals 1,000 meters. Therefore, 5 kilometers will equal 5,000 meters. So it's simple enough, really. Now, question 8. David has cycled 900 meters. David has cycled 900 meters. 900 cycle. To do with mass? No. To do with capacity? Definitely not. To do with meters, length, distance? Yeah, it is. Because how do I know? Cycled. Imagine cycling. Piece of straight line. Yeah. The distance traveled is 5 meters. That's more. That's not. That's just. I'm just showing you on the screen what I mean by length. So how do we work that out? How much further does he need to go to reach 1 kilometer? So in 1 kilometer equals 1,000 meters. Okay, so let's write that down. So you've got to write the conversion down. From the question, you know 900 meters. So if you drew a straight line, you get up to 1,000 meters. Okay, and you go to 900 meters, you know you've got 100 meters left. Think about a straight line, start from 0, go to 1,000, 900 is about there, and so what have you done? You've travelled 900 meters and you've got 100 meters left to give you 1,000. Remember, it all begins with the conversion, knowing what 1 kilometer is in thousands of meters, 1,000 meters. So question 8 is 100 meters. Now question 9. A caterpillar measures 7.9 centimeters. A caterpillar measures 7. So I'm imagining a caterpillar. You might imagine a straight line. You might say, okay, 10 centimeters is about there. A caterpillar is about there. Can you see how I'm actually making it very practical? That's what you've got to do. You've got to make it very practical. And then how long is the caterpillar in meters? So how long, the word long, can you see how I'm emphasizing certain words? Long, length, long length, is the caterpillar in millimeters. Millimeters, the word millimeters means small things. Right, so can you see how I'm verbally reasoning? Why do I use the word verbal reason? Because I'm logically working it out. I think about millimeters and I think, okay, it's to measure small things. It measures small things. Meters would be rooms, kilometers would be distances. So 1 centimeter equals 10 millimeters. That's what you write in the first line. In the third line, you draw an arrow and you say, okay, 7.9 centimeters. So if 1 centimeter equals 10 millimeters and then 7.9 centimeters, how do I go from 1 centimeter to 7.9? Well, if it was just 7 centimeters, I just times it by 1 times 7. But because it's 7.9, I do 1 times 7.9 to give me 7.9 centimeters. Whatever you do on the left, you have to do on the right. So in the first line, we had 1 centimeter equals 10 millimeters. 10 millimeters times 7.9. So if you times 7.9, when you're going to get 79 millimeters. So you need to know your place values here. You need to be able to write 7.9 centimeters, and you need to know how to shift them one place to the left. So you set unit 7 goes to the tens column, and the 0.9 goes into the units column to give you 79 millimeters. And that's as easy as it gets. Question 10. A bottle. As soon as I read the word bottle, I've now become familiar that the word bottle actually means capacity. It holds 0.5 litres of orange juice. Okay, so I'm thinking about my fridge. I'm thinking about a bottle of orange juice. I'm just pulling it out. And I'm thinking, okay, it holds half a litre. How many milliliters is this? What do I need to know first? Got you. You're right. It should be your conversion, because if you know your conversion, then that's the starting point of how to work it out. So on the first line, you're right, 0.5 litres. Then what you do, how many millimeters is this? Well, millimeters is, what you do is you go 0.5 times, sorry, 0.5, 1 litre equals 1,000 milliliters. But half a litre would be divided by 2, because 1 litre and half divided by 2, 1 over 2, gives you 0.5 litres, so it's half of a litre. So if you've got 1 litre and you divide by 2, you've got half a litre, or 0.5. So when you think of 0.5, think of it as half a litre. Okay, so you've divided on the left side. So on the right side, what do? You know that 1 litre is 1,000 millilitres. Therefore, because you've divided by 2 on the left, because from 1 litre we move to 0.5, half a litre, when we do the same on the right hand side. That's what we do. We do the same on the right hand side. Okay, so James buys some bags of sweets. James buys some bags of sweets. So I've got a bag, I've got some sweets, probably to do with mass, but we're not going to conclude yet. Each bag weighs 25 grams. So I have one bag, 25 grams. How many bags will he need to buy to have 1 kilogram of sweets? Okay, so I've got to say how many 25s go into 1 kilogram. So how many 25 grams go into 1,000 kilograms? Now, this is where you need to begin to get experienced. You need to know that these two units are very different. And because these two units are very different, therefore, you need to make the conversion the same. Okay, so what's easier? So if we know 1 kilogram is 1,000 grams, then you've got to say how many 25 grams go into 1,000. Well, we know that in 100, 25 goes into 104 times. But if you've got an extra 0, 1,000, then you just add another extra 0. So you can say that 25 grams goes into 1,000 40 times. I'm going to repeat that again. First, step 1, the units. What did we do to the units? We changed it. Changed it to what? We changed it from 1 kilogram to 1,000 grams. Why? Because we wanted to we want to see how many 1,000 divided by 25. So how many 25s go into 1,000? And what we worked out there was we just simply did it in the easy way. We said, okay, how many 25s go into 100? 4. How many 25s go into 1,000? 40. How do we know that? Because there's an extra 0 in 1,000, and therefore it's going to go, you add a 0 to the 4 to give you 40. It's easy. So, question 11. James buys some bags of sweets. Yeah, right, we've done that. Question 12. Which of these is the most likely mass of an apple? Most likely mass. Mass? What's the definition of a mass? When you're weighing something, see how heavy something is. Okay, so we're very familiar with these concepts now, these ideas. So circle the correct answer. Well, So a kilogram, A is 1,000 grams. A kilogram is pretty heavy, you know. But an apple is definitely a lot less. What about B? 150. So it's nearly between 100 and 200 grams. So it's probably almost between 1/10 to 2/10 or 1/5 around there in terms of weight. So that it's not going to be B. So sorry, it's going to be B. Now I'm just going to have to cut off because I've just got my little son coming and he's going to be a bit of a bugger. So I'm going to go now.